Good evening, everyone. So, today we are going to study. This is a session for week one for the NPTEL Environmental Geomechanics course. In this course, what we are planning to do is as the videos for the in lectures for the different weeks have already been uploaded on the NPTEL website. What we do is that we go through the previous year questions and some questions that I thought of, and then we go through these questions and see what and solve them together, and then and yeah, so that's how we are planning this session. If anyone has any doubt, they can ask me, or they can ask questions in the discussion forum of the course. So let's move towards the first question. It is about the toxic waste disposal. So, the question is that why the rock is the better candidate repository for the nuclear waste disposal. So the uh, so there are multiple options that has been given, and we go through these options one by one, and we see how what could be the answer. So first is about the low porosity and permeability. So before seeing about the low porosity or permeability, let's look at the what do you mean by porosity and permeability individually. So porosity is basically the number of pores present in a rock mass or a soil in any geomaterial, or so for example, these squares that I am drawing, these are the pores. So porosity is basically the number or the amount of pore spaces. Now, what is permeability? Permeability is basically connectedness of these pores. That means that how connected these pores are with each other, because the more connected these pores are, there is a better chance of let's say flow of water through it, or any any substance. So the more connected the pore are, the better flow it is for the water as well as oil or any other material, right? So when you say that the intact rock mass, intact means a rock which has not been broken. In an intact rock mass, low porosity and permeability are important for the repository of the nuclear waste, because if it has low porosity, it means that there are less number of pores, and low permeability means these pores are not connected. It means that even if there is a spillage of the nuclear waste in the rock mass, it first it can, since it is not connected, it cannot move further from its spillage location. So if it spill here, it cannot move very far from the location of its spillage, because the pores are not connected. And also, since the pores are less, there is less chance of the nuclear waste to be stored in these tiny pores. It means that it is an important quality for the intact rock mass. Another is about the sorption capacity. So sorption is a term. It is basically, what sorption means is that let's say we have so there are different type of sorption. Let's say there is adsorption and there is absorption. So adsorption means that if this is a particle and another substance, for example any liquid, let's say water or oil, or in this case a nuclear waste, would attach itself on the surface of this particle, that is the adsorption. That is when there is attachment on the surface. On the other hand, absorption is when there is entry. It means that a foreign substance or this waste or water or anything, um, XYZ would enter and incorporate itself into the matrix, into the matrix of this rock mass, right? So if it has high absorption capacity, what does it mean? It means that this particle, sorry, the nuclear waste, it actually it's similar to this. That is, if there is any spillage of the nuclear waste in the rock mass, it actually either attach itself to the surface of the rock, or either get absorbed by the rock, so that it will not move very far from the location. Again, it's an important quality. Another is about the densely compacted grain matrix. So what do we mean by the grain matrix? So let's say this is our rock, and we have these big size grains, right? Now if it only has like big size grains, it means it has lot of pore spaces, right? And if it has lot of pore spaces, it cannot be used for the nuclear waste disposal. But what does matrix means? That along with the larger grains, there are tiny grains, small particles, different size grains scattered across the rock. So when there are different type of or different size of grains scattered across the rock mass, so the smaller size grain would occupy these pore spaces, hence reducing the number or the amount of pores or porosity. And when they reduce this porosity, it is it can be used for the nuclear waste disposal. So matrix is nothing but the arrangement in a rock, what how the smaller as well as larger particles or grain size are arranged to make a compact, means a tight structure. And hence it is also an important quality. So all of these are an important quality in a rock mass to make it a to so that we can use it in a new as a repository for the nuclear waste disposal. Now let's move to another question. It is about geomaterial. So throughout the lectures, we have seen that a lot of many times this term geomaterial has been used. Now, what do we mean by geomaterial? So, geomaterial, since it comes from a word geo means earth. So, anything that comes from the earth, right? So, initially, it is only natural rock or soil. So, basically, since the on an earth surface there are different geological phenomena that are happening, which leads to formation of different rock structure, different type of soils. All of these come are a part of geomaterial. But what about the artificial rocks, artificial soil? So soil can be made in laboratory, or soil can be modified as well. So the new definition of geomaterial is natural as well as the artificially generated substance. For example, during construction, or during as a part of industrial waste. All of this comes under geomaterial, which we study as geotechnical engineers. So, what are the parts of the geomaterials? Rocks and soils are all already there, but industrial waste is also a part of geomaterial. So, all of this. Now, this question can also be asked that what are the in the modified and classification of geomaterial? That is the new classification of geomaterial. What are what are its significant features? Right. So these are four options. First is the representation of their contamination state. Another is about the vulnerability to decay and decompose. So as I said, so the artificially made geomaterials, which are made because of construction activities or a part of byproduct of industrial activities or industrial waste, these uh, as we include them in geomaterial, we need to understand their contamination state as well. So how contaminated they are, right? Because if you are including anything artificially formed or in the industrial or formed by industrial activity, we need to understand how contaminated they are. Another is about the how vulnerable they are to decay and decompose. So there are, even the natural soil and rock can be decayed or decomposed using method which we studied in earlier classes, that is weathering, um, erosion, all of this. So for example, physical weathering, chemical weathering, all of these are part of all of these physical and chemical weathering could affect the contamination state, could affect the soil or rock, and hence the vulnerability. That is, there are for example, let's say there are two similar type of rock, and one of them is highly vulnerable, and they are both given, they are different. So there are different types of there are same type of rock, but let's say they have different environmental condition. So one factor is that how a change in environment condition could affect the rock. So maybe in less harsh condition, this rock can survive. But let's say if the condition is very harsh, for example, very high temperature, very high heat, in that it might crack, it might decompose. In the similar sense, let's say in the same environment, different type of rock are there. So one very resistance, another not so resistance. In that case, uh, again the vulnerability of these two rocks are different, and they have different rate of decay and decomposition, right? So when we study the geomaterial, it is important to understand that what is, or to represent the contamination state as well as the vulnerability of these rock to the decay and decomposition. So hence the answer is both. Now let's